All right, for question number 3, we're going to be going over how to solve and graph linear inequalities. All right, question 3 reads, given 7x plus 2 is greater than or equal to 58, which number is not in the solution set? Okay. All right, so before we get started with solving this problem, let's go ahead and review what our different inequality symbols mean. All right. To help us with this, we're going to make a little table to the right and then go over the symbol, what they mean, and then what the graph kind of sort of looks like. All right. So let's go ahead and set this up. Okay, so the symbol column is going to be the first one. Let's take a look at the less than symbol. Okay, so this symbol right here, the meaning is less than. Now, what's an easy way to remember the less than symbol? So think about the word L, okay? L, less than. If you tilt this vertical part of the letter L, it kind of looks like this, right? So think about the L, like a L for loser or less than. It looks very much like this inequality symbol. You just have to tilt this up a little bit. And then the less than inequality symbol automatically becomes an L. Okay, so just don't forget L and less than, they both start with the same letter. So they both the same letter to start, and then it looks like the inequality symbol less than. Alrighty? Okay, so if you have a less than, let's consider if it's included or excluded. So inclusion or exclusion. Is that value associated with this inequality included or excluded? If you just have less than, it's basically an open circle, okay? Which basically means that particular point is not included. What on earth does that look like? Let's take a look at what the graph is, okay? So for example, let's say we have x is less than a, all right? If we want to graph that, we have a particular a value right here. X is less than a just basically means that you're going to go to the left of a, all the values that are less than a, excluding a. So this open circle means that this right-hand boundary is excluded from the solution region. All right? Okay, so that's the story with less than. Now let's take a look at greater than and see what the deal is with that one. So for greater than, less than points this way just like a L, greater than points the opposite direction, of course. So this is a symbol right here for greater than. Greater than. Okay? And if it's just as greater than symbol, it's excluded. This is also an open circle, all right? Because it's just the inequality symbol greater. You cannot include the actual value, the boundary point, in the solution set. So for example, if you're looking at x is greater than a, okay, and you want to graph it on the number line, all numbers that are bigger than a, so to the right of a, remember on the number line it increases to the right, right? So any number that's bigger than a is greater. So that's that for greater. Okay, so now we have that. Now let's move on to less than or equal. Less than or equal. Now we have a combination. We have a combination of equal and less than. Equality and inequality. What does that look like? We have a combination of the two. It looks like this. Less than or equal. Okay? So it's written as less than or equal. It is a combination of less than and the equal sign. Less than or equal. Okay? And guess what? This one is inclusive. So the endpoint is going to be closed. Why is it inclusive? Well, it's because of this equal component here. That means inclusion. All right. So if you don't have an inclusion component, that equal component is going to be open. All right. So what does it look like? Let's look at the graph. If you have x is less than or equal to a, what does that mean? It means that you have all the numbers less than a, including a. Okay, using the number line, less than is everything to the left. Okay, so you see the difference between less than and less than or equal to. Less than is just all the numbers less, but less than or equal to is all the numbers less, including the right boundary point, namely a. Alrighty, and you can guess what the last one looks like: greater than or equal to. Let's take a look at that real quick, because that's actually the one that applies to this particular problem that we are working on in this example. Okay, all right, so greater than or equal to is basically the reverse direction of less than or equal to. Everything that we talked about with less than or equal to also apply here, but we're just pointing in the opposite direction. Okay, so greater than or equal to, that's the symbol, is a combination of greater and equal. So it's greater than or equal to, and this is also closed. Okay, remember, is that equality component that makes it included, so it's closed. And then if we want to graph it, what does it look like? X is greater than or equal to a. If we want to graph it, if this is a, it's going to be a and everything greater and everything to the right. Okay, so that was a brief little overview on inequalities, just something to keep in mind. All right, so let's go to the problem. We want to see which of these does not satisfy this inequality right here. All right, so what we're going to do is we're going to solve it and check to see which one doesn't satisfy. Okay, so whenever they say which is not the solution set, we are basically looking for which substitution will result in a false statement. If you carry out a substitution and it's true, then that particular value is a solution, is in the solution set. All right, so we're starting with 7x plus 2 is greater than or equal to 58. Remember, when you're solving an inequality, it's just like solving an equation. The only difference is whenever you divide or multiply by negative, the inequality flips. Okay, so that's the only difference. Equality can't flip because it means equal sign, but inequalities do flip when you do that particular operation. All right, so we're just going to solve this, reverse PEMDAS, get x isolated. To do that, so it's going to be a two-step process. We subtract 2 from both sides and divide by 7. That will result in the isolation of x. All right, let's do it. So you subtract 2 from both sides of your equation, and that will yield 7x is greater than or equal to 56. It's just like we're doing a regular linear equation solve. Okay, and then next to get x isolated, we know that 7 is the relationship, the operation that binds 7 and x is the multiplicative relationship, right? So we're going to use the inverse of that, which is division. So we're going to divide both sides by 7. Okay, and then we have x is greater than or equal to 8. Now, if this were a negative, then we'll switch the inequality symbol. But we divided by positive numbers, so there's no switch in inequality symbols here. Okay, so what does this answer? This is a solution in symbolic form. What does it mean? It basically means that any number that is 8 or greater is in the solution set. Okay, any number that's 8 or greater, any real number that's 8 or greater is in the solution set. So let's go ahead and write that down. The solution set is all real numbers that are 8 or greater. Okay. All right, so let's take a look at the options that we have here. 6, 8, 10, 12. Which of these, or which one does not satisfy this condition of being 8 or greater? Option number 1, 6. Oh dear, that's an automatic fail right there. 6 is not 8 or greater. 6 is less than 8. So guess what? That's the answer. Okay? 6 is not in the solution set. Is not 8 or greater. So it is not in the solution set. All right, so that's our answer. We're not asked to find the ones that are in. We're looking for the ones that are not. So let's go ahead and check this graphically, okay, just to show you that our answer is correct. We're going to check this in two representations. Graphically, can you visualize why 6 is not in the solution set? In order to do this, we have to graph this inequality. Now, how do you graph the inequality x is greater than or equal to 8? Well, you draw a number line, and then let's just call this 8. Now we need 6, because that's the number we said is not an answer. We need 7 and then 8. So how do you graph x is greater than or equal to 8? If you review our chart right here, you just have 8 inclusive and everything to the right, okay? So for this solution set, we have 8 inclusive and everything to the right. So this right here is the solution region. X is greater than or equal to 8. Anything that falls in this region right here is good. But guess what? 6 is right here. Bam! 6 is outside. It's outside the solution region. So it's not an answer. Fail. Okay? So that's just a graphical way to verify the accuracy of our result. All right, now let's do a algebraic verification. Okay, so we have a graphical check. We know that 6 is not in the solution set. Now let's do algebraic check right here, just to let you know for sure that our answer is in fact correct. Okay, so I just want to illustrate what the whole idea of a false substitution looking like. All right, so we have the original inequality, 7x plus 2 is greater than or equal to 58. Okay, now we're going to substitute our solution that we said, the answer that we said is not a solution. So we're going to substitute 6. Okay, if we end up with a true statement, then it's a solution. If we end up with a false statement, then it's not. Okay, all right, let's do it. So we substitute 6. We have 7 times 6 plus 2. Is it greater than or equal to 58? Is this a true statement? We don't know yet. All right, so on the left side, we're just going to PEMDAS this, multiply before you add. 7 times 6 is 42 plus 2. Is 42 plus 2 greater than or equal to 58? Well, let's do one more step. What is 42 plus 2? 42 plus 2 is 44. Is 44 greater than or equal to 58? No way. That's false, right? Because 44 is less than 58. 58 changed into 5x. I don't know how that happened. So this is false, 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 false. So anytime you do a substitution and you end up with a false statement, that means that what you substituted, namely 6 in this particular case, is not a solution. So we can see for certainty that the answer to question number 3 is option number 1. Okay, so that's how you solve and graph linear inequalities.